people, thank you for clicking this video. I'm AutoGF and now we're going to talk about proving theorem of geometry. You must know what a circle is. Yeah, a circle is the set of all points in a place that are at a fixed distance from the given point, known as the center of the circle. When we are talking about the circle, we are definitely talking about the component of the circle. So, one of the components of the circle is a chords. What is a chords? A chord is a straight line joining the end of an arch. There are a lot of theorems talking about the chords, but now we're gonna discuss one of them. The theorem states chords that are at the same distance from the center of the circle are congruent. To prove this theorem, we need a visualization on it. So here's the circle with point O as the center of the circle and line AB, also CD, are the chords. Initially, we must draw the radii OD and OB. By the definitions of the radius, we know that the line OB and OD are congruent. Next, we must draw the apothegm between the center of the circle and the chords. In this step, we can use the midpoint to easier get the apothegm. So here, we get two apothegms, which are line OE and line OF. By the definitions of the apothegm, we know that the line OE is perpendicular with line AB. Also, line OF is perpendicular with line CD. After we know that the line OE is perpendicular with line AB, also line OF is perpendicular with line CD, we know that the angle OEB and OFD is 90 degrees, or is it right angle? Therefore, triangle OED and OFD are right angle triangle. And here we get OB and OD as the hypotenuse of the right angle. Before, we agree that line OB and line OD are the radius, which means they have the same length, or it is congruent. Then, by using the theorem 6.1.8, or it states congruent chords are located at the same distance from the center of the circle, we know that the apothegm, or line OE and line OF, are congruent. It is same. So here, we can conclude that the triangle OEB and triangle OFD are congruent by hypotenuse length, or HL. We already know that the triangle OEB and the triangle OFD are congruent, right? By using CPCTC, we can conclude that line EB and line FD are congruent. So EB is equals with FD. Then, before we use the midpoint to draw the apothegm, it means that the length of line AE and the length of line EB are the same. Also, line CF and length of line FD are the same too. So, if it is 2EB and 2FD are the same, so we can conclude that the length of line AB and the length of line CD are the same. It is congruent. So, it is proof this theorem